Yes. So when B decreases, the flux inside the coil also decreases. The decrease in flux, Lenz's law always oppose. So how to oppose the decrease? By increasing the flux. How to increase the flux? It has to induce current such that the field should be in the same direction of the existing field. That means if current is induced in clockwise direction, then automatically magnetic field will be inside, which will support the already existing magnetic field. So the induced current direction will be clockwise. Let us take one more example here. Here the magnetic field is outside. The direction of magnetic field is outside, perpendicular to the plane. The same thing. If let us suppose that B is increasing. If B increases, the flux inside the coil increases. Lenz's law resists that. It will resist only by inducing current in clockwise direction. When current is produced in clockwise direction, it will produce its own magnetic field into the plane, which will oppose the already existing magnetic field. So the direction of induced current will be clockwise. Current this way will produce. Now coming to the right hand side, here B is decreasing. When B is decreasing, flux inside the coil is decreasing, so it wants to support the same magnetic field by producing its own magnetic field outside. It can be achieved only by inducing current in anti-clockwise direction, I induced. So if current is in anti-clockwise direction, then it will produce its own field outward, which will support the already existing magnetic field so that it can oppose the decrease in magnetic field. So let us take one more example similar to give clear picture. This is a conducting wire which is carrying a current I. Here the current is increasing. When current increases, around every current carrying conductor, the magnetic field also will increase. So what is the source of magnetic field here? The current carrying conductor itself is the source of magnetic field. So very close to the conductor, the field lines are stronger and into the plane. As you slowly move towards right, the magnetic field decreases, and if you move farther, decreases further, and finally at infinite distance, there is no flux in the coil. So what will happen now? As you move towards right, the magnetic field decreases. Yes or no? So here, when current increases, the flux inside the coil also increases. When current in the conductor increases, the flux inside the coil increases. When flux increases, Lenz's law resists it. How do it do so? How can I resist the current? How can I resist the increase in magnetic flux? By inducing current so as to oppose the field. So if current is, it has to produce the magnetic field dots, that is in anti-clockwise direction. If induced current is in anti-clockwise direction, then it will produce its own dots, which is outside, which will oppose the increase in magnetic flux. Coming to the right hand side, here current is decreasing, so the magnetic field inside the coil also decreases. Lenz's law naturally opposes it. So decrease is to be opposed means it has to produce its own intus, that means its own magnetic field into the plane. It can be achieved only by inducing current in clockwise direction. So when current is induced in clockwise direction like this, then automatically what will happen? It will produce the induced magnetic field into the plane, which can support the already existing magnetic field. Okay? Let us take one more example. Here there is a coil. In the first coil there is a battery connected here. When the battery is closed, current flows. The current direction is like this. According to right hand thumb rule, the plane facing towards the secondary coil behaves as north pole. The plane which faces the other side will be south. So automatically around this magnetic field will be produced. That magnetic field will change the magnetic field around the secondary coil, and automatically the flux around the secondary coil or second coil is changing. Lenz's law opposes the change in magnetic flux. How can we do so? How can we oppose a change in flux? By inducing current in the opposite direction. That means by inducing current in a direction so that it can oppose the already existing magnetic field. So it has to produce the magnetic lines in this direction. How can we do it so? By inducing current in this direction, shown clearly here. Check it out. So when the current flows this way, here current flows down, so that the magnetic field will be opposing the already existing magnetic field. So finding the direction of induced current is one of the very important aspects. Similar example here. If you see this, the first coil is a closed coil, the battery. The moment you close the key, current is produced in it. The direction of induced current will always be, see here, when current is produced, automatically current will flow this way. So this side behaves as a north pole, the other side behaves as south pole. So it will send its own magnetic lines, right? Around every current carrying conductor, magnetic field will be there. That magnetic flux will try to change the magnetic flux of the secondary coil, the second coil. So the flux around the secondary coil is changing, therefore Lenz's law won't mind the flux. But here there is a change in flux. Lenz's law will try to oppose the change in flux. So induced current will be such that thumb should point in this direction. The magnetic field should be in this direction. That means current will be induced the way it is shown here clearly. Okay. Now one very important and interesting example here is current is constant. You are moving the coil towards right. When you move the coil towards right, the flux inside the coil is decreasing. Why? As you move away from the current carrying conductor, as the distance increases, magnetic field decreases. So you are moving from a region of maximum flux to minimum flux, therefore flux decreases. Therefore when flux is decreasing, it will oppose the decrease in flux, so it has to increase in flux. So magnetic flux lines are into, so it has to support the same field, so it will produce its own intus by inducing current in clockwise direction. When current is induced in clockwise direction, the decrease in flux can be opposed. It is in accordance with law of conservation of energy. If the same coil is moved in this direction, there won't be any change in flux. There won't be any induced current. When you move it along x-axis, then only there will be change in flux. Okay. So here also the same thing. If the coil is moved this side, the same story. Here if you move it down or up, no induced current. There will be induced current, that too in the clockwise direction, only if you move it towards right. And last but not the least, very interesting example. There is a U-shaped metal frame on which a conducting rod of length L is kept. The whole apparatus is kept in a magnetic field which is acting into the plane. When the rod is moved towards right, the area enclosed by the magnetic field is increasing. Therefore flux inside this closed portion is increasing. So initially this is the flux. When you move it towards right, the flux region increases. It is moving towards right. Therefore now the enclosed area increases. Flux increases. When flux increases, Lenz's law always resists the change in flux. In order to oppose the change in flux, it has to create the induced current so that it will produce its own dots, the field in the opposite direction. How can it be achieved? By inducing current in anti-clockwise direction. So in the loop, current will flow in anti-clockwise direction, so that the induced magnetic field will be outward, which can oppose the already existing magnetic field. So the increase in flux can be opposed. Thank you. Let us meet again.